Shall we start? Anup? Anup?
Yes, sir.
Shall we start?
Okay, sir.
Okay. So see in the previous class if you have attended, so in this previous class I have explained regarding the arrangement of the turbocharger and superchargers. Okay. In that compressors are being used for the supercharger that we have discussed regarding the centrifugal charger. Now we'll go for the rotary blower type chargers. Okay. Now in this diagram you can see the rotary blower type charger. So see this is what the casing is there. This is what the outer casing is there, and these are the two rotors are been elliptical shaped two rotors are been attached on the shaft. At this shaft backside there is an gear, two equal gears are been attached to that shaft so that this rotor can moves in an equal speed. Okay. So this rotors, this type of rotor superchargers works like an gear pump, water gear pumps. Okay, this works on the equal speed and rotates on the equal speeds and compress the air and throw it outside. Now you can see in this the air is inserted inside from this this position, or you can say the inlet. Okay, this is the inlet from where the air is coming inside, and these rotors are moving in this direction. In some slides I have prepared for you all, I will show at last moment. Before that you see the rough textbook construction over here. It has been compressed, then afterwards the air may be passed from this side or from this side, or from the compression it may be passed from this outer sides. Okay, so how these types of rotary compressors are being used for generating in high pressures and the compressed air, okay, which is been transferred to the engine for the combustion purpose. And one more vent type blower is there, you can see in this diagram over here. This is a vent type blower is there, you can see. So over here this is an inlet and from this is a outlet. So this vent type blower works on the eccentric axle of an motions. Okay, so see over here there is a rotor is there, okay, which works in an eccentric movement. What do you mean by the eccentric movement? That at the if the any sorry, so you can see over here the rotor is moving on this center axis. At the center there is a shaft. On this shaft, the at the center axis this rotate this roller is been moving. But over here there is a center shaft is there, but the movement of this rotor or the vanes are not in the circular movement. It is in an eccentric movement. You can see over here it is an eccentric way. Okay, and these are the vanes are there, in which these vanes are been small slots are been provided for the casing, in which the air is been trapped, and due to the movements of this vane the compression stress is being generated, due to which the air is being compressed and one of the outlet is given within the body from where the compressed air is been coming out. So this is how the vane blower works. Now you can see, I will read some few points for you all. Okay, this is a positive displacement rotary type supercharger. This consists of a cylinder casting a rotor within flow slots. Okay, the remains in the contact with the casing at least at a one point all the times. Okay, so see you can see over here remains at a contact with the casting at least one time. The rotor is an eccentrically molded on the vane slides. So see this is a rotor inside over here, the round is it is a rotor which is molded on the vane slides in and out of the rotor slots, and these are the rotor slots. Over here you can see these are the rotor slots on which the rotor is been moving. Okay, the air is induced in this space. So over here in this slot there are the blank spaces in which the air is been induced between the blade due to the outward movements of the van, which increase the space between the blade. So see, it is moving in an eccentric manner, it is not moving in a circular manner. When it comes to the outer position, okay, it comes to this outer position over here, when it comes to this outer position over here, so over here there are those, in the slots there is an empty space or the blank space is generated in which the air is been filled. Then afterwards, when it comes to this position, when the rotor comes to this position, then afterwards what happen, the air which is placed in that empty space is been compressed and throw it out to come out by the outlet of the casing of the body. This is how the vent blower works. When the space reduces at the outer let of the supercharger, it discharges the air. The space between the inner surface of the body and the drum decrease the inlet to the outlet side. Okay, the space between the body and the rotors vents, okay, this makes the inlet and the outlet of the airs. The air which enters at the inlet decrease in the volume, hence the presence, hence the pressure increases as the air reaches the outlet. Then the movement of the vents causes the flow of flourishing and the noisy. So this types of superchargers, okay, vent type blowers are been very noisy one. Okay, now we go for the next thing, that is advantage and disadvantage of this type of centrifugal charger, roots type chargers and vent chargers. So the advantages and disadvantages: low initial cost with a less power and high low initial cost with a less power requirement and high conversion efficiency. So centrifugal charger having the low initial cost, okay, less power requirement and high conversion efficiency. It requires a less maintenance, this is one of the advantage, and handle in any quantitative air. It's require more space due to the larger impeller. So this is what the major disadvantage of the centrifugal pump. Now we'll go for the rotor blowing pump. It is in simple design, low capital means the investment is low and also the maintenance cost is low. This is of the advantage of the rotary blower. The volumetric efficiency is higher and better balance is possible at an high speed. So volumetric efficiency, whatever the air is been produced and the engine giving the volumetric efficiency, okay, that can be possible at a high speed also. This is one of the advantage of the roots blower surface. The change of an leakage are more, air supply is not regular due to the pulse delivery. So see, this is what the disadvantage is there. The change sorry, the changes of the leakages may occur. Due to that leakages, the percentage of the compressed air what it should be done is less, and that means what, the efficiency of the rotary blower is less. Okay, is not regular, the regularly doesn't compress the much more higher. Okay, the air, as the pressure increases, the volumetric efficiency of the supercharger decreases. So over here, due to the, this is what the major disadvantage you can see in the rotary blowers, that as the efficiency, as the pressure increases, the volumetric efficiency of the supercharger decreases. Why? Because there is an leakage in the rotary, okay, due to which the pressure is increases, but the volumetric efficiency in the engine is going to be decreased due to the leakage of the pressure. Advantage and disadvantage of the van: suitable for the high capacity of the engine. Okay, so why it is suitable? Because there is a rapid movement of the engine, so the exhaust gas which is coming out by the turbochargers get enters in the compressor by the means of intercoolers, so the van can delivers the faster, what I can say, the faster air pressure to the engine. The high pressure ratio is possible and deliver larger quantity of an air. Okay, this is what the advantage. Now the maintenance cost and the power requirement is on high. This is what the disadvantage of the van blower. Okay, the van rubs against the cylinder and wear and tear outs rapidly. So the vents which are there, which are rotating or reciprocating within the slots, okay, the continuous reciprocating of the slots with a rapid movements goes for the wear and tear. The maximum wear and tear occurs in this slots. Now let us see the supercharger limitations. The parameters such as the engine knocking. In the previous class I have told regarding the knocking. What do you mean by the knocking? If there is an incomplete combustions in the petrol engine, okay, if the petrol supplied to the engine which is not burnt properly, so there will be the pressure will be generated. That pressure force the pistons to move in a downward direction. Okay, that is an BDC center. At that moment some sounds are coming out. Sorry, the sound is coming out. That sound is called as an knocking sound. So even though you have observed when you are putting in petrol, okay, by a less octane number. What do you mean by the octane number? Octane numbers are the such numbers which indicates the combustions of the fuels. Okay, with the less octane numbers the fuel combustion becomes very less in the engine. If you are having a petrol from the any of the petrol pump to your bike or the car, so you can not in the car you can observe the much more knocking, but in the bike you can observe it. So the engine sound is coming there while when you increase the speed. Okay, uh, some type of cutting sound is coming from the engine. Okay, that sound is called as a knocking sound. Why this sound is coming? Because the petrol which you are added, the fuel which you have added to the engine, okay, for the combustion purpose, that is having a less octane number, due to which the combustion doesn't occurs in the engine properly. Okay, incomplete combustion of the fuels, incomplete combustion of the fuels makes the incomplete, if there is an incomplete combustion of the fuels which makes the engine damage, and as well as the pistons movement is also been stopped over here, due to which the sound is coming. That sound is called as a knocking sound. Okay, when the piston is moving from the BDC to TDC, from bottom dead center to top dead center, at that moment the force is generated that doesn't allow the pistons to move at the topper side, that is a head dead center. Okay, due to which the knocking is sound is coming out. Okay, that can be what you can say, these parameters. Okay, by the superchargers you can avoid the knocking by using some parameters. Okay, then the thermal and the mechanical load limits the power outputs of the engine. What do you mean by the thermal? So see, thermal and the mechanical load. So mechanical loads is directly the from the engine, whatever the output is coming out by the means of axle shaft, it is going to the gearbox. From the gearbox that load is been transmitted to the wheels, okay, for the rotations. And then the thermal is nothing but the temperature which is increased in the engine due to the continuous combustion occurs. The heat is generated over here and continuous movements. Okay, that this all the things, knocking, thermal, mechanical loads, okay, that this all the things which you have to control by the supercharger when you use the superchargers. Okay, now let us see what does happens in SI engine and CI engines when you use the supercharger. In SI engine the extent of a supercharger is mainly limited by the knocking. Okay, so see the main in ignition combustion engine, what is that, sorry, spark ignition engine is what is that, the main problem is that knocking. Okay, in the petrol engines the supercharger reduce the ignition delay. This results the engine knocking this high pressure. Okay, so what happens when you use the supercharger and turbochargers, due to which if the air is not supplied, or you can say the air is not supplied when the fuel is been, sorry, when the air and fuel mixture is not supplied in the engine cylinder in a proper manner, So what happens when the ignition occurs, when the spark is occurs, the fuel doesn't burn in a proper manner. If the air density is decreased over there, the fuel doesn't burn in a proper manner. Proper manner in sense means what? The percentage of the fuel which is should be burned, that doesn't burn in properly. Okay, due to which the knocking occurs, detonations occurs, okay, by which the engine parts may get damages. Okay, so for this important parameter is there, that the knocking of the engine in SI engine should be controlled by the supercharger in such a way that the air supply of air with the mixture of fuel should supply in a proper manner. Understood? Now we'll go for the SI engine. In SI engine, the supercharger limits are not due to the combustions. Okay, in this the combustion doesn't matters over here, because over here the fuel is been injected over here. Okay, the engine runs better, smoother and quite due to decrease the ignition delay at a high supercharging pressure and the temperature, but the degree of supercharger is limited by the thermal and the mechanical load. So so in the spark ignition engine, what is happening? The knocking is happening. Okay, the parameters of the supercharger should control that the knocking can be controlled in the engine. Now in the combustion, internal combustion engine, what is happening? There is no fuel injector is there, the fuel is the injector is there, due to which the fuel is coming due to as per the stroke. Okay, the combustion may occurs, but over here what the parameter is to be controlled, that is a thermal and mechanical load. Thermal load, just now I have told regarding the thermal. What is the thermal? So due to the continuous of the four stroke engine, okay, due to the continuous movement of the engine, the heat is being generated. Due to that heat, the parts of the engine, that just like a cylinder or the pistons, may undergoes for the damages for the excess heat. Okay, that has to be controlled. And also the air fuel mixture should be controlled in a proper heat tolerance. Okay, that should not be increased beyond the heat, so that the engine parts may get damages. Okay, now next that is a mechanical load. So see, if you have seen, the petrol engines can run faster than the diesel engines, for example I am telling that. Okay, why? Because the petrol in the diesel engines, the combustion uh, doesn't compared to the petrol engine, the combustion is not in a proper manners. Okay, because the stroke, because of the stroke, the flow, sorry, the flow of an fuel is not burning properly, because not of the proper air supply is been given to the engine, due to which it affects the engine load. Okay, output engine load, that due to that output engine load, the universal joint which is been given for the shaft from the gearbox, which is transferred to the wheel. Okay, that directly affects on the speed of the wheel, rotation of the wheel. Okay, for that reason the supercharger should be controlled by saying these parameters in the CI engine, so that the thermal and the mechanical load can be controlled properly. Okay, as well as in SI engine for the knocking system. So these are the important parameters which are to be uh, taken into the consideration while designing or assembling the superchargers, and this is also one of the important limitations of the superchargers in the engines. Okay, now let us go for the turbochargers. Let us see how does the turbochargers works. If the gas turbines runs on an exhaust gas of an engine drives the supercharger, it is called as an turbocharger. So see, the engine, okay, from the engine the gas which is the burnt gas which is coming out, that is called as an exhaust gas. Have you seen from the silencer the gas is coming out? That is called as an exhaust gas which is coming from the engine. By that help of that exhaust gas, a turbine is being run. Okay, from that turbine the compressor is going to run. Okay, the exhaust gas is being utilized for the for the rotation of the turbine. Okay, that exhaust gas is being used for the rotation of the turbine. Due to the rotation of the turbine, the compressor is running. By that compressor, once again the fuel pressure or the gas fuel and gas pressure is being generated, and which is been introduced or been inserted in the engine. Now by the diagram I will try to explain you how does this works. Okay, so this is what the simple diagram is there on which the turbocharger works. Now you can see over here, this is an engine is cylinder is there, in which the piston is there. From this piston, sorry, piston is there. Over here the two valves are being given. One is an inlet valve and another one is an, this one is an inlet valve and this one is an exhaust valve. Okay, once the cylinder starts moving, okay, the fuel uh, the fuel and the air mixture, after the combustion occurs, okay, the fuel is being burned, the whatever the gas is been released by this cylinder, okay, by the engine, that exhaust gas enters into this turbine over here. Okay, this turbine, from this turbine, okay, so before going to this explanation, I will like to explain you the construction, then you can understand properly. So see, this is one's exhaust pipe is there and this is a turbine is there. This turbine is connected to the compressor by a means of shaft. Okay, by a means of shaft. From this compressor the air fuel mixture is been sorry, this compressor is connected. For this compressor is connected to the another pipe, that is an air fuel mixture which is coming from the carburetor, okay, from where it enters to the compressor, and this is what the turbine is there, for where the exhaust gas is entering. So and this is the waste gate or the accumulator, you can see over here, and this is a mixture and this is the inlet of the engine oil, and over here you can see the spark plug, this is a piston and this is a connecting rod and this is a crankshaft. Now, so in the previous classes I have explained 3 or 4 different types of arrangement of the supercharger and turbocharger. Okay, the compressor is connected directly to the engine, okay, to compress the air for engine load, so that the compressor can rotate and compress the high pressure air which can enters in the engine. And the another one arrangement you have seen, the turbine is connected to the compressor. With the help of that turbine, the compressor rotates and compress the air to a high pressure and introduce into the engine. Same way, if the turbine is used for the rotation of the compressor, these types of superchargers are called as an turbocharging. Okay, now here see the working. So see, we will start with the exhaust. So the exhaust gas is coming out, it comes and dashes to the vanes or the blades of the turbines, okay, at the speed. So it dashes to the blades of the turbines, allows the turbines to rotate over here. Once the turbine starts to rotate over here, there is one more outlet is there from where that exhaust gases are been coming out and comes disappears into an atmosphere. Okay, but before going to atmosphere, disappearing to the atmosphere, it dashes to the turbine blades and allows that turbine blades to rotate. Once that turbine blades are being rotated with the help of that exhaust gas, okay, that these turbine blades are connected to one single shaft. That blades allows the shafts to rotate also. Then this shaft is connected to a compressor. Now you can see this shaft is connected to a compressor. As the turbine rotates, this shaft also rotates. This shaft rotates, the compressor also starts to rotate over here. Okay, once the compressor starts to rotate over here, it takes the air fuel mixture. You have seen the different types of compressor now: centrifugal compressor, rotary type compressor and vane type compressor. From that, any one type of the compressor in been used, which sucks means what, inlet the air fuel mixture, okay, compress within it, and then afterwards it delivers with a high pressure to the engine. Then once again in the engine the high density air is been enters, which allows the combustion system, the fuel is been burned completely in the engine. Then afterwards what happens, when the fuel is burned, the air is been burned, whatever the burned gases is there, that also then once again it comes out through the outlet and enters to the turbine. Like this way the cycle of burned gases used for the rotating of the turbine and the fresh air air fuel mixture enters in the compressor, works continuously for 800 200 400 rpm per cycles. Okay, so this is how the simple construction of the turbocharger works. So I will like one more, I will like to share you the slide one more. So if you are observe, you can see on your screen, so please reply me Anup. Okay, just I will share you the slides. Can you see it?
Yes, sir.
Okay, now you can see over here this see, this is the engine where the combustion is occurring over here in the red mark, you can see over here. Okay, sorry, I am using a phone, so it is difficult to me for making a ppt, but I have tried something for you all. Okay, so I am not having a laptop, so let it be. Okay, so see, in this engine you can see over here there is a combustion is occurred. From this combustion you can see over here, we'll go backside. Okay, this is the exhaust gas which is coming out after the combustion. Okay, from this exhaust gas, wait, okay, now it is done. From this exhaust gas the turbine is running over here. Okay, this turbine is connected to the compressor. See, this turbine is connected to the compressor, from where the this compressor is connected to the carburetor, from where the air fuel mixture is entering to this compressor. Okay, then it is been compressed. Okay, this compressor is rotated by the help of this turbine. You can see over here there is a turbine is there. With this help of this turbine the compressor is been working. So the how this turbine is rotating, from this engine the exhaust gas is been coming out. Okay, whatever the waste gas is there that is coming out from this engine dashes to the blades of the turbines and allows the turbine to rotate. Okay, once this turbine rotate, this turbine is connected to this compressor by the means of shaft is there at the middle. Okay, this shaft also makes the compressor to rotate. Okay, in this compressor the gas are being entered that is an oxygen or the fuel gases. Okay, or the liquid fuel which is enters in this compressor, by which the air mixture with the fuel is been compressed. It enters to the, due to the compression, see one more thing is that due to the compression the temperature is also increase of the fuel, sorry, gas. Okay, or the air fuel mixture, so it should be cooled to before entering the engine. So over here the intercooler is being used. So I will explain in the deep what is the intercooler and how does it intercooler works in the next slide. Okay, so over here the intercooler is used. You can see the color of the gases over here. So the different color shows the temperature indications. Okay, so over here there is a fluorescent orange color is there, which shows the very hot gas enters to the turbine by which the okay, from the turbine. So see, keep in your mind, from the turbine the air is not not entering in the compressor. Okay, just the turbine is connected by the means of shaft for rotating the compressor only. No air is been rotated. Whatever the exhaust gas is been enters in the turbine, that is coming out. You can see in the arrow mark, that is coming out and disappear in the atmosphere. Okay, just turbine is used for rotating the compressor. In the compressor the air is coming by the means of carburetor, in which the proper mixture is done of the fuel and the gas, and it comes enters due to the compressor compressed air. The pressure and the temperature is also increase of that air fuel mixture. That air fuel mixture in the intercooler, it is been cooled down, but the pressure is not dropped, only the temperature is cooled down, and that air fuel mixture is been entering in the engine for the combustion purpose. This is how the turbocharger works. Okay, now in the next slide we will see. So see over here, the emitted air, that is emitted entrance of the air. Dense air means what? The compressed and the pressure air which is entering. Now this is a turbo is there, which is connected with the compressor. We can see in the middle over here. Okay, and this arrow mark is nothing but an exhaust air is been passed. When the turbine is rotated, then afterwards there is an outlet is given, from where that exhaust gas is been disappear into the atmosphere. Okay, so this is what the slides shows, how the turbo and the compressor works. Now you can see this is a 3D image over here of a turbocharger. So see, the arrow mark shows that how does the air allows the turbine to moves. Okay, once the turbines moves, the excess air is been come out by the in the outlet of the turbines. Okay, now you can see in the middle there is a shaft is there, and which is connected to the compressor. The air enters from the carburetors in this compressor, which rotates over here and been compressed and generates a high pressure and passes to the intercooler. From the intercooler it passes to the engine. I will go for the next. So this is what the rotary vane pump is there. So this is pump. I have taken this diagram to show how does the rotary what you can say rotary supercharger works, how the compressor works. So the gear pumps and the rotary pumps works on the same phenomena. Okay, not sorry, the vane pumps and the vane supercharger works on the same phenomena. You can see over here it works on the eccentric directions. Over here eccentric directions means what? Not rotate in the center axis. Okay, it works rotates in an eccentric. Now you can see there are the some vanes are there, there are slots are there. Over here there is a rotor is there. When the air enters from this sides, get collected into that slots. When that air is been collected into that slots, in the next rotation the vanes are been compressed over here. So see, these are the vane slots are there. At this sides you can see, okay, this sides you can see over here, these are the these vanes are the larger ones, and these are the smaller ones. When the eccentric movement of the vanes comes at these moments, the compression is being generated. Due to that compression, the high pressure is generated, and here the slot is increased, due to which the air is been high pressurized and come out by the outlet by the these sides. Okay, this is how the vane pumps works. Now see over here, in this also the circle is shown, how the eccentrically the movement is occurring of this vanes. Now you can see over here. So see, this is a color diagram. These are the hot gases, and this is the inlet gas in the red mark, and the blue you can see the outlet. How does it works? This eccentric moves in a rotary directions. It compress. Okay, open the space of the rotors, sucks the air inside. Then once again the eccentric movements come to the inlet side, it compresses, and these spaces of the rotors are being opened, from where the air is been exhausted or makes its make its for the outlet of that pumps. Okay, Now this is a simple diagram of the rotor type centrifugal. Okay, you can see over here the air is been entering over here, the both the rotors. Okay, so over here you can see there is a slight gap is given between the both the rotors. Okay, slight gap for the movements of the rotors, so that wear and tear should not occur between the rotors. So how the compressions is occur from the side, they are lifting one. Now see over here there are the two sides inlets they have given, this side and this side. So in some types of pumps there are two inlets are there, also the single inlets can be there. So in the previous 2D diagram I have shown you that diagram, in that a single inlet is there, from where, from this side, from the bottom side or from this side the air is been inserted over here, the from both the sides are been inserted. So by the side, from the side of the rotors the compression is been occurs, and at the top you can see the outlet is been going out. So in previous 2D diagram I have explained regarding the. Now see how the rotors are there connected to these two shafts. These shafts are connected with the common gear teeth. Okay, these are the common gear teeth, so that you can get the uniform common rotary motions. These rotors moves it in a common speed. This is what the simple construction. Now see over here you can see this is a supercharger, compressed air and the cooled air over here. This rotors moves. Okay, you can see over here from where the air is been compressed and it comes out from this compressor and it enters to the intercooler. From this intercoolers it enters to the engine. Okay, so this is how the supercharger works. Now let us see regarding the intercooler. Okay, so the intercooler is one of the important, you can say, the device which is used in the supercharger and the turbochargers. So we are going to study regarding the functions, importance, constructions, location of the intercooler and the working of the intercooler. How does it works? Now let us see the functions. So see, the main function of the intercooler is that it has to convert the hot air into cooled air. So the hot air enters in this intercooler over here. Okay, it cools in the intercooler and it comes out in an cold temperature. Okay, the temperature of the air is to be reduced before entering the engine. That is done by the intercooler. This is the main function of the intercooler. What is the importance? So see, the temperature and the density plays a very important role in the intercooler. Okay, sorry, temperature and the density plays very important role in the engine working. So see, if the temperature of the fuel air mixture, the fuel air gas mixture is meeting is over. Hello, Anup.